name's Ashley May. I'm Senior Design Manager with Breed UK, and my role on the project was to deliver the civils, structures and the specialist areas, which included microscopy and the clean room. The client, Cardiff University, purchased the site. It was an old railway sidings and yard, so it was a brownfield site. Ground required remediation. There were obviously chemicals and diesels and a lot of nasties in the ground, so there was a remediation strategy. We had a piled solution, nearly 1,000 piles under the buildings. The two buildings were basically RC frames, and we had steel structures attached to them. So here in the TRH we have a 5-storey steel cub. The clean room itself is a steel structure, but more importantly the microscopy suite is actually a more traditional ground bearing design. The microscopes that the end user uses are very sensitive to two things: vibration and electromagnetic interference. So it's very important from an early stage to assess what the influence of the railway was or was likely to be on the completed structure. So we employed a specialist from California, specialist in seismic design and seismic assessment, and they informed the structural design, not only for the whole site, but specifically for microscopy. What that meant in terms of physical build, we had to dig through the remediated ground until we found fresh strata. We then had to go a further 3 meters down and start building back up in layers. The slab ranges from anything from 600 millimeters thick to areas where it's 1,200 millimeters thick, and in places it's nearly 2.5 meters thick. And that is specifically under the keel pit. So yeah, the AC stem room, where the new tool is housed, one particular design feature of that was a keel block. So a keel block is basically a cube of concrete that is sat on the foundation, and because of its mass, it helps to mitigate vibration. So the challenging thing is there's probably only a handful of keel blocks that have ever been delivered in the UK, and our specialist, who actually installed an air suspension system to the keel block, said that the last one he done was about 10 years ago. So although very sensitive microscopes are commonplace, the facility or the base upon which they sit is very specific to this facility, and that has really helped with the performance that they're seeing so far. The function of the microscopes uses obviously electron beams and what have you, so they're very sensitive to magnetism. So we had to engage with a specialist to design 2 different Faraday cage solutions. So a Faraday cage helps to dissipate the perturbations and creates a stable environment within it. So the 2 main microscope rooms both have Faraday cages, one of a slightly lower performance and one of a much higher performance. The suite is designed obviously to house these sensitive electron microscopes. So as you enter the suite, there are 2 SEMs, which are scanning electron microscopes, and you've got the FIB, which is another type of electron microscope, the TEM, which is the first tool that has a shielded room, that's a tunneling electron microscope, then the AC stem, which is the brand new tool that the client has purchased, and that is in the most vibration sensitive area, and it has the most protection from the Faraday cage. From a personal point of view, this is probably one of the most challenging projects I've worked on. Certainly the longest. It's run into 4 years now, although not 4 years on site. And as a result of it, probably the most rewarding project I've ever worked on. So we're very proud to have been part of it.